Alright, so in this lesson here we are going to learn how we can solve a rational equation. Okay, and so allow me to quickly bring in and show what it means by being a rational equation before we actually learn the solid methods of how we can solve any one of these rational equations. Alright, so these are some quick examples of what a rational equation is. So mainly, again, the idea is what we have in any of these equations here is what we have is an equality, left-hand side being equated with right-hand side. There's a left-hand side being equated with right-hand side. And then in any of these right here, we have the unknown being the x. So that's just the general idea about solving an equation. So any of these is an equation with the unknown x. But now the reason now we call these, any one of these, a rational expression simply because the equation itself now involves terms that are rational expressions. So this equation here, left hand side has two rational expressions and the right hand side has one rational expression. And this equation here, the left hand side has two rational expressions, that 1 over x and the x minus 1 over the x plus 3. So the equation being regarded as a rational equation anytime the terms of our equation, any one of the terms that involves a rational term. Okay, and that's what it means by being a rational equation. Alright, so now allow me to bring in one demonstration example, and along the way right here I should be able to introduce the method that going side by side with how I solve the rational equation in this particular demonstration example. Alright, so now we have come to our first example here, and as I said, I'm using this example here as a demonstration example so that we can see the methods, and I will put the method, the step-by-step method into how we can solve this rational equation. Okay, so alright, so now for this particular equation, and just like any other rational equation right here, we have a step-by-step instruction as a method right here. So now this is the how-to instruction for how we can solve a rational equation. The first step, we need to note any value of the variable, or another way of saying any value of the unknown that would make any denominator 0 value. We need to note any value of the variable that would make any denominator 0. So in this equation that we have here being a rational equation, we have three rational expressions here. And so we have three separate denominators. Here's one denominator, x plus 2. Here's another denominator being x minus 2. And this is another denominator being x squared minus 4. Okay, so we have three separate denominators. So we need to spot out, that's what first step is all about. We need to spot out all possible values for x that cause any of these denominators to be equal to 0. Okay, and so in that way right here, I can immediately see that x must be not equal to negative 2. Because when x equals negative 2, x plus 2 will equal 0. Okay, so we must take note of this particular value right here. So the point now is that the final answers to this, the unknown must not equal negative 2. Okay, because the negative 2 will cause this denominator equal 0. Aside from that, I would see that we must exclude out x equals 2 here, because this value of the unknown will cause this particular denominator equal 0. Now, what about that denominator here? Then I can see that either x equals negative 2 or x equals 2 will both make that denominator here equal 0. So that means we don't have any additional values to be noted about making the denominator equal 0. Alright, so now we are ready to get into step 2, where we start proceeding into solving this rational equation, where we have already made note that the final value of the final values of the unknown here must not equal negative 2, neither equal to positive 2. Okay. Alright, so now after the first step here that we have noted any value of the variable or the unknown that would make a denominator 0. we advance now to step 2 right here, where it says we need to find the least common denominator of all denominators in the equation. So in our equation here, 3 rational terms here, we have 3 separate denominators: x plus 2, x minus 2, and x squared minus 4. Okay, and so we must bring in our skill that we have learned previously prior to this lesson right here about how we can find the LCD of the 3 rational terms here. Okay, so let's find the least common denominator throughout all 3 rational terms here. And so after using our skill right here, we can come up with least common denominator to be x minus 2 times x plus 2. And so in this way right here, needless to say, since the part of the work here as part of the steps requires your skill to be able to find the LCD, the least common denominator between the 3 or all the terms of your rational equation. So make sure to review and get your skill in finding LCD going. Okay. All right, and so now step 3 of the instruction of the method right here, we will clear all the fractions by multiplying both sides of the equation by the LCD. So the main goal here is to clear out the fractions, the rational expressions. But to do that, we must multiply both sides of the equation by the LCD that we found from the previous step. And so this is how it's going to start right here. Our equation. With this equation, I am going to multiply both sides by the LCD. So the LCD was found being x minus 2 in product with x plus 2. So that will be multiplied to both sides. So x minus 2 in product with x plus 2 is multiplied with the left-hand side, and the same LCD is multiplied to the right-hand side. X minus 2, x plus 2 is multiplied with the right-hand side. Okay. And so, but exactly how do we clear out the fractions? Because we have fractions here. So yes, we multiply the LCD to both sides, but how does that cancel out the fractions? So here's how it works for the next step. So in the next step, keep in mind that this is one factor, even though it's a product of 2 little factors right here, but it's one expression being multiplied with 2 separate terms. One expression multiply with 2 separate terms. And so in that way, the distributive law says we can multiply this underlying expression here with just the x plus 2 over x plus 2. So 2 over x plus 2 is going to get multiplied with the x minus 2 times the x plus 2, according to the distributive law. Then that entire underlying expression will be multiplied with this other separate expression, making it now plus 4 over the x minus 4 over x minus 2 will be multiplied with x minus 2 times x plus 2. And the right-hand side, x minus 1 over x squared minus 4 will get to be multiplied with the product x minus 2 times x plus 2. So the key here is we treat this product here as one entire expression, or one bigger factor right here, to be multiplied to both sides of our equation. So now, still, I'm just only on my way to show how we can clear out the fraction. So I was saying, on the left-hand side, that underlying product right here, or expression here, was multiplicatively distributed to each term. And that one was multiplied as how it was earlier, so it was kept the same here. Now, I can see that x plus 2 will cancel with this x plus 2 in our first denominator. So in my next step, it's leaving it 2 times x minus 2. This is where we must bring in our skills in simplifying a rational expression. Okay? Now, this, the way how it reads, 4 over x minus 2, that rational expression is multiplied with the product of x minus 2 times x plus 2. But we recognize a common factor, x minus 2. That x minus 2 will get canceled with the other x minus 2 in the denominator. And now the entire expression here turns into plus 4 times the leftover factor here is x plus 2. And that is how, once again, I said that I cleared out that the fraction in my second term here. But clearly that requires, once again, your skills in being able to simplify a rational expression where we have common factor. Okay, so in that way, it's a little unclear right now, but the x squared minus 4, allow me to bring in a quick extra note, x squared minus 4 can be easily factored as x minus 2 times x plus 2. So the way how this rational expression looks, x minus 1 over x squared minus 4 means it's the same as x minus 1 all over x minus 2 times x plus 2. And so now we recognize there's these two factors are both common with those two factors that we multiply to both sides. And so now the entire denominator here will get canceled with that, leaving it now what's left behind here, x minus 1 on the right hand side. All right. So now on this side of my board right here, that equation we have arrived at from the most recent step on the other board right here. I just now rewrote that here. Okay, but at this point right here, we are completely free from the rational expression. We are free from fractions and making it a lot easier. So here we can just simply bring in our skills in terms of how to solve these the basic equations, linear equations. So each one of these parentheses, I'm going to multiply the 2 here, making it in my next step 2x minus 4. I am going to distribute that 4 to each term here, making it 4x plus 8. And as I said, these are skills that anyone viewing the video lesson here should be familiar with. Or in case you're feeling unsure, go ahead and review your background learning. And that equals x minus 1. And the equation keeps getting easier and easier for us. So now we can go ahead and combine like terms. So 2x plus 4x on the left-hand side, making it 6x minus 4 plus 8, making it 4. And that equals x minus 1. And now I'm going to rearrange the terms by bringing all the unknowns to one side. So I'm going to subtract x from both sides. And now making it 5x plus 4 equals negative 1. And so our equation now appears to clearly be a linear equation. And so now I'm going to subtract 4 from both sides. And now making it 5x equals negative 5. And we can divide both sides by 5 at this point right here. Okay. So starting with this step right here, every single step I'm doing here should be familiar with anyone viewing the lesson. So once we have arrived at this point right here, I can leave it a little flexibility for anyone learning from the lesson to take your own route to solve the equation. Okay. But now in my route that I took right here, then 5x equals negative 5. I divided both sides by 5 at that point right here. And so it comes out x equals negative 1. Okay. And what I just did there was step 4 of our instruction right here by let's solve the resulting equation. This was what the instruction referred to as the resulting equation. And this resulting equation now should be is the one that brought it back to something that's very familiar to anyone of us doing the problem, solving the problem. And then we take out work here in solving that resulting equation. So the resulting equation here is the equation that after we have cleared out all fractions. Okay? And so now after solving the resulting equation, there's one final step right here. Make sure to discard any solutions that's found from step 4 that are among those that we noted in step 1. So now allow me to recall. So this is all of the solution. This is the only solution we have found from that resulting equation. So we found x equals negative 1. Those values of the unknown that we noted to be excluded are still listed here. X should not equal negative 2 and x should not equal 2. So our solution here is not among any of those that listed. And so now this is legitimately our final answer. We found only one value, we found only one solution throughout, right after this resulting equation, after clearing out all of the fraction, and then we found that one solution. And that one solution here was not among those to be excluded, that to be noted for exclusion. And so in that way right here, we have come to the final solution. This is our final solution. I'm saying that when the unknown x equals -1, this the left-hand side of this equality will equal to the right-hand side of that equality. All right, so now we're in example 2 right here, where I'm gonna go ahead and repeat the instruction right there. And this time I won't swing back and forth between the board here and the computer screen that often anymore, because anyone viewing the earlier example has already seen the instruction, the major method right here. So now I'm just gonna strictly carry out the step-by-step instruction here into solving this rational equation. Okay. And so for this equation right here, we got 3 rational terms right here. And so be ready for any number of rational terms. So we have 3 different denominators. Okay, so quickly as a note, that term right here on the right hand side is a simple one. So x minus 4 being a denominator, this denominator will equal 0 when x equals 4. So let's note that down. And now indeed we don't want x to be equals 4. So we note that down as x should not equals 4, or x must be other than 4, or x is not equal to 4. That's a requirement. So our final solution must be at least aside from that value right there. Now that other simple denominator here that we have spotted here, x minus 1, this denominator here will equal 0 when x equals 1. So in that way right here, we don't want our final answer to the equation, we don't want our final value of the unknown to equal 1. So the unknown that we eventually would find out must be other than 1 and other than 4 by far. And now this denominator here, it will equal 0 when x equals 4 and also x equals 1. And so these two that we have already noted and excluded out also satisfy this denominator being non-zero. And so now all of those values we have spotted for that can lead to a 0 value in the denominator have all been spotted and listed here. Okay. The next step now is to get the LCD. So LCD for our problem here. Once again, you must bring in your skill of how you can find LCD for multiple denominators. And so the LCD I can find here is going to be x minus 4 times x minus 1. And now to organize the problem a little better than example 1 right here, this x squared minus 5x plus 4, as a note right here, is simply x minus 1 times x minus 4 in complete factor form. Okay. All right, so now we are ready for getting into that step where we are about to clear out all of the fractions here. And so in what I recommended earlier, in the next step where I actually write down the equation here, let's keep this denominator on the left-hand side in factor form. So our equation before clearing out fraction, left-hand side is indeed x plus 11 over x minus 4 in product with x minus 1. That left-hand side equals to, and now we have 5 over x minus 4 minus 3 over x minus 1. So that's just the original equation. The only difference is I wrote that left-hand side denominator as factor product. But so now in order to clear out the denominators, to clear out all of the fractions right here, I'm going to multiply the LCD that we found previously into both sides of our equation. Now making it the left-hand side, we have x minus 1 times x minus 4 as one huge product to be multiplied with this entire rational expression. The right-hand side, I'm going to the entire expression being grouped together here with the two terms, I'm going to multiply x minus 4 times x minus 1 to the right hand side. All right, and so in that way the algebra work comes in. Now allow me to handle the left hand side first in my next step here. So there are two terms in this grouping parentheses. So I'm going to multiply that entire underlying product right there as one huge factor, as one huge expression to each of my two terms here. So that's to be multiplied with this and to be multiplied with that. Okay, and so I'm going to produce the following. 5 over x minus 4 is to be multiplied with the x minus 4 times x minus 1. And minus, now my entire term 3 over x minus 1 will be multiplied with x minus 4 times x minus 1 again. Like I said, we take the entire underlying expression right here as one big factor, as one big expression to be distributed to each of our terms right here. And it would be even better that I put that in parentheses, put those in parentheses. All right. The left hand side for now, let's keep that unchanged. So from the previous step to now, nothing changed yet. I have x plus 11 over, there's x minus 4 in product with x minus 1 in the denominator, and we multiply with that giant expression x minus 1 in product with x minus 4. All right, and so now we are right at the corner of being ready to clear out all fractions. So here's how I'm seeing the entire big terms here has common factors between denominator and that numerator. So now x minus 1 is a common factor that gets cancelled away. X minus 4 is a common factor that can get cancelled away. So the resulting term, after cancelling all common factors on this left hand side term here, comes down to x plus 11. That equals, now this first term in our right hand side, x minus 4 is a common factor with the x minus 4 in the denominator. And then now we have only these two remaining factors, both in the numerator. And so I have the resulting expression, 5 times x minus 1. And we have that factor right here, that huge product right here as one entire expression multiplied with this rational expression right here. We have one common factor, x minus 1, being recognized. So we cancel those away. The resulting term now becomes minus 3 in product with x minus 4. All right, so now with our resulting equation right here, after we have cleared away all fractions right here, and I've had this equation written on the other board earlier. So with this equation, it's a lot easier to solve, and anyone viewing the lesson here should be able to take your own approach, should be able to take your own route in terms of solving this. Okay, so personally for me, I would just simply first continue by distributing that 5 to each of my terms here, and distributing that minus 3 to each of my terms here. Okay. So in my next step, the left hand side remains exactly the same, but the right hand side becomes 5x minus 5, and no more parentheses. Minus 3 times x is a negative 3x. Minus 3 times negative 4 is plus 12. That's how I do it personally. But like I said, this is now not the only way of finding the unknown for this resulting equation. Okay, and so now observing this equation of mine a little further, I want to arrange all the x terms in one side so that it's just my approach right here that I want to keep the x terms in one side so that it's all gonna come after combining like terms being a positive term. And so in that way, I would see that if I subtract both sides by x right here, then the resulting equation after combining like terms is gonna make it as following: 5x minus 3x, making a 2x, minus another x right here, making it simply a positive x. Okay? And in the meanwhile, let's combine like terms between minus 5 and 12 right here. That's now making it plus 7 The left hand side here gives me just 11. All right. And the equation keeps getting easier and easier as we rearrange terms and combine like terms on both sides. And so now at this point right here, I'm so ready to solve for this current equation. Minus 7 from both sides. That's resulting in 4 equals x, or a better way of reading it, x equals 4. All right. So we have followed the methods and cleared out successfully all of the fractions. And this is what we came to as our resulting equation after clearing out fractions. And we took our time and we took our favorite methods to solve for this resulting equation. And we ended up, and you can always rewind the video here and to find out that I didn't make any error here. But we came down to x equals 4. We came down to x equals 4. So recall from the instruction, we definitely need to check to see if our found solution of the resulting equation here is among any of those spotted value that would make a 0 denominator. And so x equals 4 here, we have spotted at the beginning of the problem that, hey, x should not equal 4 and x should not equal 1, because x equals 4 will make that denominator equal 0. Or if x, for any reasons, after solving, come out to negative to 1 right here, would make that other denominator to be 0. And any one of these will make that denominator here equal 0. So in that case right here, the solution that we found, this value of the unknown that we found, which is only the only one, is now ruled out right there, because it's unfortunately among those that we spotted out to be excluded. Okay. And so in this case right here, we cannot take this solution. We cannot take this solution. So as a matter of fact, the entire equation, the true answer now is said to be, we have no solution. Okay, we have no solution, and specifically for this value that we solve right here, for this value that we solve, I'm not taking that as a final answer, but it has a name. So you've seen the process. We spotted that there has to be a few values that we must exclude, and unfortunately our solving work ended up with that value right there, where it was right among those spotted values that would make some denominator equal 0. And so in that way right here, x equals 4 specifically, not our final answer, but it's regarded as an extraneous solution. Okay, so as a definition here, an extraneous solution to a rational equation is an algebraic solution that would cause any of the expressions in the original equation to be undefined. Okay, and so in this case right here, we've learned a new term here. This x equals 4. We did our work all correctly, but unfortunately that value here ran right into among one of those that we have spotted out as to be excluded, because they would make some denominator equal 0. And so in that case, this solution here is called an extraneous solution. All right.